Hello, my name is Ike McKinley, and this is NOS 220, Linux System Administration. This session, we'll be looking at Linux file systems and how they function. The file system is the basis for data storage in any Linux system, and so we'll be taking a look at the various file systems available, their strengths and weaknesses, how a file system works, and what we mean by a file system journal and why it matters. And finally, we'll take a look at how to use file systems for different purposes. Basically, the file system is a way to organize data on a hard drive so that Linux can retrieve it later. As we mentioned in an earlier video, each partition or logical volume has its own file system, and all file systems are mounted in various subdirectories of the root file system. Each file system exists separately, and damage to one file system has no effect on others. Any file system organizes data into what Linux calls nodes. Each node is linked with a particular file, and multiple nodes can be linked to a single file. More on that in a bit. The file system also uses directories to organize data. A directory can contain both files and other directories, which themselves can contain the same thing, files and directories. When a directory contains other directories, it is called the parent directory. The relationships are usually expressed vertically, with changes into contained directories being down, and changes to parent directories being considered up. Thus, the root directory, which is the root file system, is the topmost element in the directory structure. Files, on the other hand, represent the actual data, either stored as text or in a binary format. Binary files can usually only be accessed by the program that created them, whereas text files can be read by almost anything. An executable file is a binary file that can spawn a process and make changes to the system. Each file or directory represents a node, and each node is effectively a pointer to a location on the hard drive where the data is stored. Users can use the ln command to point multiple nodes to the same location, either indirectly using the symbolic link with ln-s or directly with the plain ln command. There are a number of file systems available for Linux. The standard file system is the ext4 file system, with the older ext3 also being still relatively common. These both have journals, but are otherwise similar to the ext2 file system that was the original basic file system for Linux. A journal allows changes to be made and those changes to be stored in case the file system fails. So upon recovery, a journal is read to see what changes were pending when the file system crashed. All of these file systems offer the same basic performance characteristics. They perform better with a few large files, are somewhat slow in deleting large files or large numbers of files, and are generally fairly reliable. An alternative to the ext family of file systems is the XFS file system, created by SGI. This file system has been available on Linux for some time now, and is touted as a superior replacement for enterprise use. The XFS file system generally exhibits better performance with extremely large and extremely small files, and also has the fastest delete time for almost any files, though this is most notable with large files and directories. Another enterprise alternative is the JFS file system designed by IBM. Like XFS, JFS claims better performance with very large and very small files, and generally better performance overall. JFS also claims less fragmentation over time than other file systems. But JFS is also the newest of the enterprise file systems in Linux, and so is less mature and has less of a track record. It also has lower adoption than XFS, so it hasn't been as widely tested. Finally, there's the now almost defunct Riser FS. Once considered one of the most promising replacement for EXT, Riser FS is now languishing after its creator and maintainer became involved in a somewhat sensational murder case as the defendant. Work on the file system has all but ceased. Riser FS is still an excellent file system, though, for large numbers of very small files, addressing one of the original weaknesses of the EXT file systems. And it could be used still for temp directories and other areas where large numbers of small files may reside. Each of these file systems has its uses, but it is important to realize what those uses are. Linux organizes the root file system into several basic parts. The /bin, /sbin, and /usr directories all contain executable files and the information that those files need to run. The /boot directory contains system boot information. The /etc directory contains configuration for the system. And the /home directory contains user data. Finally, the /var and /tmp directories contain data on ongoing system activities, usually temporary in nature. So, each of these systems can have its own file system with different performance characteristics. The executable directories have data that almost never changes, and so reliability is more important than performance. On the other hand, the /var and /temp directories are constantly in action and usually have many small but unimportant files, so performance tends to be paramount. Today we've gone over some of the aspects of the Linux file system structure. We looked at how the basic structure of the file system works and how it organizes data. We looked at the different file system options available in a Linux system and their strengths and weaknesses. And finally, we looked at how to use those file systems to build a working Linux system structure. Next time, we'll be looking at network configuration and management.